Creating a volume collider for the monster is a bit more straightforward than creating it for the building. So I'm going to start by object merging in this monster mesh from assets_monster and the out monster null. I want to use the real monster mesh for this and not the convex decomposed version, because our real mesh will give us better collisions, and for a dust sim we don't have to worry about using some convex decomposed proxies for this. Now we don't need to collide with all the different parts of this creature, so I'm just going to select the parts we're interested in. So I'll select his body mesh and some of these big horn things, and maybe those horns or spikes on his back as well, and I'll grab these. And we don't need any of these other little spikes in his face or teeth or saliva or anything like that. So I'll hit delete and flip that to delete non-selected. And after isolating those meshes, we can unpack that and convert that to regular polygons. And we currently don't have any velocities on this creature, so let's trail this to get some point velocities on there. So drop in the trail sop, flip this to compute velocity, and I'm also going to polyfill this to create solid objects. Right now he has a lot of open faces in this mesh, and this will help our VDB conversion if we polyfill this prior to creating our collision VDBs. So you can drop in that polyfill sop, and the fill mode probably doesn't matter too much, but I'm going to select triangles, and I'm also going to subdivide this for a bit more accuracy on this mesh. The subdivision is an optional step since this might be accurate enough already for our collisions, but I just want to make sure that this is even more accurate by adding that extra subdivision. And now that we have the holes filled and the velocities added and some subdivision for accuracy, we can go ahead and create our collision volume with our VDB from polygon sop. And we'll connect that to our subdivide. And as before, we're going to call this collision instead of surface. The default voxel size of 0.1 looks like it's probably accurate enough for this monster here. There's not nearly as much detail in the monster as there is in the building, so we don't have to use quite as high-res a collision volume here as we did for that complicated RBD fractured geometry in our building. Now, as we did before, we're going to turn on fill interior, and we're going to add the velocity surface attribute. So we'll select the point.v and the attribute dropdown, and we'll set that vector type to displacement/velocity/acceleration. So you can see we have both the collision volume and the velocity volume here. As before, we can also hide that velocity if we only want to see the collision SDF. So I'll copy that visibility sop from the building setup and paste that underneath our monster here as well. And of course we'll add a null, and I'm going to call this source collide monster. Now it can be very helpful to check our velocity data before running the simulation just to make sure that all looks correct, and to check that data we can use a volume trail sop. And this volume trail expects some points in the first input and the velocity volume in the second, and this will display some streamers to show the velocity motion within that volume. And you can create those visualization points in various ways, but I'm going to use the points from volume sop, and I'll connect that to the first input of the volume trail. I'm also going to add a null at the beginning of this so that we can connect any volumes that we want to this null in order to check those velocities. And we'll connect that to our monster. And if you display the points from volume, you can see that we're getting a ton of points added to that monster area. This is a lot more than we really need for our visualization, so we can turn up that point separation to make this a bit more sparse. I'll turn that up to 0.3, and you can also add some jitter if you'd like to break up those point positions. And then for the second input on our volume trail, I'm going to isolate the velocity volume. So let's drop in a blast SOP, connect that to our check volume null, and in the group, I'll type @name equals v. Then we'll flip this to delete non-selected, and if we display this blast, you can't see anything in the viewport because we've hidden the velocity volume, but if you middle mouse on there, you can see that we've isolated that correctly, and then if you connect that to our volume trail SOP and display that, you can see we now have some streamers to visualize the velocity vectors that we'll be adding into our sim. And to make it a little bit more convenient to view both the building velocities and the monster, I'm going to set up a switch for this, and I'll connect both the monster and the building to that. So now we can use this same visualizer to check the velocities in our building as well. Now, one way to modify and control this velocity influence is to modify those point velocities on the mesh before the volume conversion. In this case, I found that the velocity influence from the monster's head and spikes and shoulders were a bit too much and kind of pushing that dust around in some pretty weird and unnatural ways, so I just wanted to blend out that velocity influence entirely. So I've time shifted to freeze that monster mesh in place, and I painted white on his hands and lower arms and smoothed that out a bit and left everywhere else completely black. And with this color data painted in, we can use that to blend out the velocity and the dark areas. And to use that color to blend out those velocities, we're going to add a point wrangle after the trail that computes the velocity. And you can connect the painted mesh to any of those inputs, and then use this bit of vex to multiply the velocity times the color value. In this case, I'm just getting the red component of the color value and multiplying the velocity by that, so that will leave us with velocity influence on his hands only, and we can verify that by looking at our volume trail. Now, to add the monster collider to our simulation, let's dive back inside the DOPNet, and I'm going to make a copy of the building collide source, and we'll paste that in next to it. And then for the monster collider, we'll point that SOP path to source collide monster and wire that into the merge for all of our volume sources. And as I've mentioned before, as a rule, I always make sure the camera volume source is last, so I'm going to switch that in this merge order. And then as you run your simulations, you can tweak all of these various influences to your liking. I found that in my simulation, I didn't need a whole lot of influence from the actual monster's velocity, so on this scale multiplier and the volume source for that monster, I wound up using just 0.05 for my final simulation, but I would absolutely encourage you to play around with different levels of influence for all of the various velocity sources in your scene. And with that monster collision volume added to our simulation, I'm just going to do a quick file cache on this as well, so that we don't have to calculate that on the fly, and then we'll run a flipbook to see what the sim looks like. Now with this flipbook complete, we can play that back and see what it looks like with those collisions applied, and this is starting to look pretty cool. We still have some work to do to add detail and get rid of some of these very round shapes, but the overall broad strokes of the sim are coming together, and it's looking pretty promising. It's also worth noting that I'm using this volume visualization SOP to help control the overall look of this dust and to get this a bit closer to what our desired look in the render will be. In this case, I turned up the density scale by 3 and the shadow scale by 2. If you just look at the raw output from the DOP import field SOP, you can see this is looking very bright and a bit harder to see, whereas cranking up that density and shadow scale is making this a whole lot more visible and it looks a bit nicer. Maybe I went a bit too heavy with that density scale. It's probably a bit too dense here, but this is one of those things that we'll have to play around with in our render.